All right, guys, my apologies for the technical difficulties. Here we go. All right. Anybody have any questions from the homework last night? How'd you do? The simplifying, which one? Simplifying what? The one with the radicals? Yeah. Okay, can I do one for y'all real quick? Anybody else need that? Okay, Sugar Baby, you got to put that up. Is that breakfast? Okay, you got to put that up, Sugar Baby. All right, let me pull up an example. You know what, I have one in here that I can do. This one, like this? All right, here we go. So we have 4 times the square root of negative 20 times 3 times the square root of negative 48. The first thing you need to do, you see that 4, you see that 3? Everything up there is being multiplied, right? Okay, so how about we multiply 4 times 3? What does that give you? 12, right? So now I have 12 times the square root of negative 20 times the square root of negative 48, right? You with it? So now let's break down the square root of negative 20 here, right? Because remember that negative symbol means I'm going to have an I on the outside because the square root of negative 1 is I, right? So it's I times the square root of 20, right? Clear? And then pick up your calculator that I need to pass out, right? And just type it in. So when you get your calculator, folks, go ahead and throw that away for me, please. I'm sorry. What is the square root of 20 equal to? What is the square root of 20? 4 root 5, right? You said how much? Oh, 2 root 5, I'm sorry. So this will be I times 2 root 5, right? But how would I clean that up? Well, 2I root 5. Okay, cool. So now I have 12 times 2I root 5 because the square root of negative 20 simplifies to 2I root 5. So far, so good? So now I need to do the same thing to the square root of negative 48, right? Let me come over here. Square root of negative 48. Just break it up into pieces, right? And bring that I out. So that's I root 48, right? What do you think you should do now? Hello? Do it. Y'all looking at me. 4 root 3, okay. So that's I times 4 root 3. Rewrite it. That'll be 4I root 3, right? All right, cool. So look. 4I root 3. All right. Getting somewhere. Still need to bring some stuff back together though, right? So really now you need to look at this like this. Okay, all of these pieces are all being multiplied together. This literally says 12 times 2 times I times the square root of 5 times 4 times I times the square root of 3. Put the pieces together that merge together, right? 12 times 2 times 4. I can merge those numbers together, can't I? What's 12 times 2 times 4? You have a calculator. All right, 96. And then I have an I and an I, right? What's I times I? I squared. Now, you're going to have to reach in the back pocket and remember something from possibly middle school or Algebra 1. When you multiply the square root of 5, or when you multiply two radicals that have different radicands, you simply multiply the radicands together. So the square root of 5 times the square root of 3 is going to be the square root of 15. Okay? Now, we talked a lot about what I squared is equal to. What is I squared equal to? -1, right? So when I simplify this a little bit further, I get negative 96 root 15. Bam, done. Make sense? You might not like it, but do you understand it? It's a bunch of pieces of what we did individually the other day, right? On Wednesday. All right, so now let us switch gears to dividing complex numbers. Yesterday we multiplied and we talked about powers of I, right? Okay, but today we're going to be dividing complex numbers. Let's go. Now your text wants you to recall that expressions in simplest form cannot have square roots in the denominator. Now you just watched a video about this very thing. When you have an I in the denominator, essentially what you have in the denominator is the square root of -1, right? Isn't that what I equals to? It is improper to have a square root symbol in the denominator, all right? Now, the text goes on to say that because the imaginary unit represents a square root, the square root of -1, you must rationalize any denominator that contains an imaginary unit, okay? You can't have I in the denominator, period, all right? You cannot have I in the denominator. That's what you need to remember. To do this, multiply the numerator and the denominator by the complex conjugate of the denominator. Lord, what is a complex conjugate? What is that? What is a complex conjugate? I'm about to say. Okay, so essentially this, young people, if you start off with a complex number a plus bi, okay, the complex conjugate of a plus bi is very simply going to be a minus bi. Notice a didn't change, bi didn't change. The only thing that changed was the sign in the middle. If you start off with positive, it's going to become negative. If you start off with negative, it's going to become positive. If you start off with addition, it's going to become subtraction. If you start off with subtraction, it's going to become addition. Okay? Now, that's in theory. Let's make it real. Y'all want to do a problem now? Let's do it. Let's go. Look at that. Look at that. Go ahead and write down this expression. We have 3 plus 10i divided by 5i. First question, do I have an I in my denominator? Yes. Yeah. So I need to rationalize my denominator, okay? Must be rationalized. Now it looks weird because I just told you, if you start off with a plus bi, it's going to become a minus bi, right? Need y'all to understand something. This really says zero plus 5i, right? They're just not going to have a zero up there, right? So if my denominator is actually 0 plus 5i, okay, what's going to be my complex conjugate? Let me write it here. Complex conjugate. What is happening? In this case, if it starts off with 0 plus 5i, it's going to become 0 minus 5i, right? Starts off with addition in the middle, and then it's going to become subtraction. Notice nothing else changed, only the sign in the middle. Now, are you going to write 0 minus 5i? No, because remember, 0 plus 5i was actually just 5i, right? So the complex conjugate of 5i is very simply going to be negative 5i. We good? Now, the text just told you in the previous slide that in order, and I'm going to erase it over here as well. Okay. How we doing? We okay? On the complex conjugate? Now, we must rationalize the situation to get the I out. Watch this. I'm going to multiply the numerator and the denominator by the complex conjugate. What's my complex conjugate again? Negative 5i. Negative 5i over negative 5i. Now, what is actually happening, young people? I'm not changing the value of this fraction, all right, of this ratio. I'm not changing the value of it. I'm just changing how it looks. Because y'all, what is negative 5i divided by negative 5i equal to? It's equal to 1. Because when you divide something by itself, it becomes 1, right? And what happens when you multiply any number by 1? It stays itself. I'm multiplying by 1. I'm not changing the value of 3 plus 10i over 5i. I'm just changing what it looks like. Okay? Because remember, they say you can't have an I in the denominator. I'm about to manipulate the situation so that I no longer have an I in my denominator. Does that make sense? I'm not changing the value of the expression. I'm simply changing how it looks. All right, so let's go. Let's multiply. So this is going to be multiplied by negative 5i, and this is going to be multiplied by negative 5i. Well, this is just going to be simple distribution, right? So 3 times negative 5i, or negative 5i times 3 is going to give, we did this yesterday, right? What is it going to give me? Hello? Thank you, negative 15i. And then negative 5i times 10i is going to give me negative 50i squared. Yeah. Just multiplying. We did that yesterday, right? We're just multiplying complex numbers, that's all. And then in the denominator, 5i times negative 5i is going to give me what? We're multiplying. What is 5i times negative 5i? Yes, indeed, Luca. Negative 25i squared. Boom, we just multiplied. We did that yesterday. Right, Miguel? You with me, sugar? All right. We did that yesterday, y'all. We sure did. Only thing that's different is that you have to do it in the numerator. You have to multiply in the numerator and the denominator. Same thing. I already taught y'all how to do this. I really feel bad for having a teacher. All right? So now guess what I'm going to do in the numerator and the denominator now? Yeah, I'm going to simplify it. I see an I squared, and I know that I squared equals what? Negative 1. So now let's simplify, shall we? So on my next line, I'm going to have negative 15i, okay? I'm going to put the step here, but some of you all know that negative 50i squared is just going to be plus 50, right? Okay, but let me put the step. Sum box separated. Minus 50 times negative 1. And same thing down bottom. Can I go ahead and say negative 25 times negative 1? Can I do that? So on the next line, I'll have negative 15i plus 50 over a positive 25. All right, cool. Let me come here. Ooh. It's so ugly. What did you say? Isn't the 50 positive? 15. No, it would not. That's an I, not an I squared. You got me? Okay. So the only time the sign changes is when you have to mitigate the I squared, not the I. If it's an I, it's like an X. It doesn't make any difference. It's like a variable. Okay. Forget this little stupid arrow. I'm just going to come here now. So now, young people, I'm going to rewrite my numerator so that it's in proper complex form. Remember, the real number portion must come first. So I'm going to rewrite this as 50. Okay. Take that positive 50 and put it in front of negative 15i over 25. Okay, I'm almost done. Now I'm looking at each of these terms and I'm like, they all have something in common. I can simplify this situation, right? Each term can be divided by the same value. What is that value? 5. Did you say 5, baby girl? Give me your name again. Mariah, thank you, baby. Yeah, they all can be divided by 5 and simplified accordingly. 50 divided by 5 is what? Huh? Thank you. 10. Who said 10? Thank you, baby. Thank you, sugar. Was that Alexis? All right. Minus 15 divided by 3. Y'all better talk to me. What did I say? 5. I'm sorry. 15 divided by 5. Uh-huh. Bless the teacher. And then finally, 25 divided by 5 will give me, bam. Now I'm done. And that's my final answer. Okay? Now, in the event that they want everything pulled apart and written separately, okay, you would have to splice your denominator, like so. Just want to be thorough with this, okay? So we have 10 over 5, okay, minus 3i over 5. You see what I mean about splicing the denominator? You would apply the denominator to each term in the numerator, okay? Does that make sense? And then, as you can see, I can further simplify this, can't I? Since I've spliced my denominator. 10 divided by 5 is what? So this would be 2 minus 3 over 5i. This answer is acceptable, as well as this answer. It all depends on how they want you to format the answer. They tell you they want it in A plus BI form. This is the one that you would need. If they don't make that indication, check your answer choices. But the first answer would be sufficient. All right, how we feeling? Dividing complex numbers ain't nothing but multiplying complex numbers. You just have to insert the complex conjugate. Let's do another one. I'm gonna take that off. Hold on, guys. All right, sorry for the delay. Here we are, new situation. We have 2 plus 8i divided by 4 minus 2i. This is more traditional, okay? My denominator is a traditional complex number, right? Okay? So we said, if you have an I in the denominator, you have to rationalize the denominator, right? And you rationalize it by multiplying the fraction by the complex conjugate divided by the complex conjugate. Well, what is the complex conjugate? Second? It's the whole thing. Say again? That's the original. So if I started off with subtraction, what do I change it to? Yes. So what is my complex conjugate? Yes, ma'am. Yes, ma'am. Very good. So I'm going to multiply by 4 plus 2i over 4 plus 2i. Okay? Make sense? And remember, all I'm doing is multiplying by 1. I'm not changing the value of the expression. I'm only changing what it looks like. Okay? Y'all ready? So let's multiply now. Okay? But what's different about this situation is that I have essentially two binomials here, right? I got to do FOIL up top and FOIL down bottom. Let's go. So I got to multiply 2 times 4, right? Okay. Isn't this what we did yesterday? Same thing, except I got to do it in the numerator and the denominator, right? So 2 times 4 gives me what? Uh-huh. And then 2 times positive 2i gives me what? Plus 4i. All right, cool. And then it's going to be a little messy. Let me change the color. 8i times 4 gives me what? Thank you. Okay, so that'll be plus 32i. And then 8i times 2i gives me what? 16i squared. We good? Okay. I hate changing the color like that. Sorry, y'all. Is that confusing to see it that way? We okay? All right. So let's do the same thing down bottom. 4 times 4 gives me 16. And then 4 times 2i gives me Mariah, right? And then let me change the color so it's not so messy. Negative 2i times 4 gives me negative 8i. Thank you, Alexis. And then negative 2i times positive 2i gives me what? Negative 4i squared. Very good. How we feeling? We're doing 2 problems at the same time. That's all this is. 2 multiplication problems at the same time. Right? Miguel, how you doing over there, babe? Huh. Angel? I feel like you guys are so far from me. How we feeling? Shantasia, what you doing, baby? You good? You writing with me? Okay. So let's simplify the numerator, shall we? Combine my like terms, handle the I squared, right? So I have now 8. Sorry, y'all. Ooh. All right, so I have 8, but I got to combine the 4i with the 32i. What is that? Yep, 36i, right? And then this I squared will make the 16, the positive 16, a negative 16. Can I just go for it? Okay, just write the negative 16. Yeah, I can do that. And then down bottom, what's going on? Well, 8i minus 8i is going to become what? 0. Ooh, Spence, I hear you, baby. All right. So let me write the 16. Nothing's happening with that yet. 8i minus 8i is 0. Do I have to write plus 0? I'll write it. Fine. All right. But you don't have to. You don't have to write that. Just, just being thorough. And this negative 4i squared is going to become plus 4, yes? How are we feeling? We okay? Let's keep going. Y'all see some other, and if you feel free to go ahead to work ahead if you feel, the urge to do what you should do. So at this point, now I have another set of like terms, right? 8 and negative 16. When I combine those two values, I get a negative 8, right? Plus 36i. And then down bottom, 16 plus 4 gives me 20. Oh, technically that's, we're not done, but there we are. Now, negative 8, 36i, and 20 all have a common factor. What is it? It's 4. It is the greatest common factor. So if I divided each of these elements by 4, I would get -2 plus 9i over 5, okay? And if they wanted it in complex number format, I would splice my denominator. And my final, well, if they don't indicate that it has to be in complex number format, that could be your final answer, or -2 over 5 plus 9i over 5 would be the final answer. All right? Any questions about splicing the denominator? How we doing? Anybody remember what time we get out of here? 10:30? Okay, good. Thank you, baby. Do this one. Do this one. 3 minus I on your own. 3 minus I divided by 2 minus I. Top to bottom. Top to bottom. I want everybody to try to get to a final answer on their own. When you're finished, I'm going to come and clear you, and you can move on to the Delta Math assignment, okay? How y'all feel? Is this making sense to y'all? Anybody want to fight me? Not yet? Miss, you want to go? What's the complex conjugate? 2 plus I. Yep. Hold on, sugar baby, let me see. Let me see. Very nice, very nice indeed. Yeah. Give me the splice denominator version. And then you're good to go. You can move on to Delta Math, kiddo. Good job. Very nice. Can I get a 1 over 5i? Can I get... It's the same thing, but I just want you to understand that you may see the answer like that. You good? All right, very good. Very nice, very nice, very nice. Great job, guys. That's it. Only difference, let's see, 7/5. That it's kind of tricky with the one. You may see the answer like that.
Oh, okay.
With instead of just the one by itself in the numerator. Good job. Let me see, sugar. -1? Fix it. Let me see that denominator. Probably the same thing happened in the denominator. You got a -1
Yeah,
there?
yeah.
Fix it. That's it. That's it. Wait, why you still got a minus right here? Why you still got a minus? You got a plus right there. Why you put a minus right there?
Because the
Mm-mm. Why is your I negative? What's 3 minus 2, sugar baby?
I always doing it the other way around. I was thinking -3.
How we doing, folks? Anybody need help? No, just the sign in the middle. Just the sign in the middle. You got a question? It does. So let's see, you said 3 times 2 is 6. 3 times I is positive 3i. Negative I times 2 is negative 2i. Negative I times I is negative I squared. Yeah, it's a new term. Okay? And don't forget 2 plus I over 2 plus I. Keep going, you on the right track? A massive one, I don't know. All right, so let's just start with the like 3i minus 2i is what? Come on, we're ready. That's it. So then, when you splice your denominator, that would be 7/5 plus 1/5. Some of you all have been writing it like this, 7/5 plus I/5. That's cool, but you'll probably never see it like this. All right? What is that in front of the 6? Oh, is that an arrow?
Yeah.
Oh, okay. Yeah, keep going, keep going. Negative I times positive I is a what? Negative I squared. Be careful, okay? Let's see. All right, so we have 3 times 2 is 6. All right. 3 times I, where's your 3i? There you go. And then negative I times 2 would be a negative, so I already have it in there. Okay, cool. And then perfect, all right. And that's all over. Did I touch something? Okay. So that's 4. Don't forget your signs. So why do you have a double negative here? Okay, so 2 times 2 is 4. So like even here, I want you to say 6 plus 3i minus 2i. You don't have to put those extra symbols there because it just muddies the water. But I appreciate using parentheses, and those are not necessary here. Okay, minus 2i, take that parentheses off as well. And that one up there too. All right, so 4 plus 2i. All right, minus 2i. And then negative I times I would be a negative I squared. All right, so now we have like terms in the numerator and the denominator. Go ahead and simplify. That's how you don't back here. Got it? All right. You get it. All right. So what? So 6 plus I minus I squared. So minus I squared will become what? Think about it like this. It's a negative 1I squared. Remember, there's a 1 in front of there, right? Negative I squared is really negative 1I squared. So that negative 1 will become what? Just a positive 1. Okay?
Oh,
Okay. That's not okay. What did you try to use a previous example? What did you say? Have you been writing anything down? Okay, so you can move. You can't be over here no more. You gotta come up here by me. Yeah, baby. Oh yes. Oh yes. Yeah, man. Yeah. Only issue is this one in the middle. Because look, 2i minus 2i is what? No, 0. It won't be anything. You haven't done anything yet. Come on, come on. Both of y'all can move. Come on. Shimmy on over. Come on. Let you slide on over here by me. Oh yes. Talk to me. You got a question? You gotta get up. Come on here. Where you get 2 from? What's 6? 6 plus 1 is what? That's a square root of negative 1. But we're not going backwards. Right? You feel me? All right, y'all, I'm about to work this problem out. Come on. Don't tell that one to pack up that little backpack. Who did I not see yet? Luca, did I look at your paper? I looked at yours. Taiwan, did I look at yours? Baby, what's up with your paper? You need to know enough of something? 7 plus 5, okay. That's gonna be a negative 1? Look up here. Negative I squared. The root is just like saying negative 1I squared, right? So that I squared will make the negative 1 or what? Second? Yes, it's good. All right. I'm gonna finish up here. Why do you have like 2 I's in you? It should not happen. Because an I squared, it shouldn't be I over I. Because when you rationalize, the I is supposed to go away. Remember, that's the whole point of rationalization. What? Oh, there you go. Okay, come on. Write this out with me. Let's go. You writing with me, right? All right, so we're multiplying these two quantities together and these two quantities together, okay? So 3 times 2. You are writing with me, sugar baby. And Daniela, right? You're just checking your progress and you're gonna pick up like where you left off. Okay? If you feel comfortable, keep working, okay? All right, 3 times 2 gives me 6. 3 times I gives me 3I. And something that I noticed too, guys, you all are writing your I's, but they're not very distinct. All right, they look like little ones with maybe like a little wayward mark above them. That's why I put that little squiggle on it, so it looks like an I. There's no mistake about it. So make sure your I's are very distinct. Does that make sense? All right. And it was hard for me to kind of tell the difference between an I and a 1. All right, so picking back up. All right, 3 times 2 is 6. 3 times I is 3I. Negative I, let me change colors. Negative I times 2 gives me a negative 2I. And then negative I times I gives me a negative I squared. Okay, so far so good? All we're doing is FOILing. Angel, do you have a question? All right. So now in the denominator, we're going to do the same thing. 2 times 2 is 4. 2 times I is a positive 2I. Okay. And then let me change colors. Negative I times 2 gives me a negative 2I. And then negative I times I gives me a negative I squared. Okay. Now I have like terms in the numerator and the denominator. Let's mitigate that now. Here are my like terms here. So 3I minus 2I is just going to be 1I or just I, right? So I'm going to rewrite it as 6 plus I, all right? Now you see this negative I squared? Let me go up here for a little sidebar. Remember, that's the same thing as saying negative 1I squared, right? And remember, the I squared changes the sign of its coefficient. So if I have negative 1I squared, when I replace the I squared with the negative 1, it's going to become positive 1, right? Okay. Daniela, does that make sense? Oh, yeah, I can. Let me start over. All right, so we have to simplify negative I squared, right? Have to simplify negative I squared. But remember, negative I squared is the same thing as saying negative 1I squared, right? Are we okay with that? Now, what is I squared equal to? If y'all don't get out of here, I will fight y'all in front of this whole class. You don't miss me. All right. So what is I squared equal to? Negative 1. So I'm going to say negative 1 times negative 1, right? And what is negative 1 times negative 1? Positive 1. And that's it. Okay? So this is going to be 6 plus I plus 1. Because negative I squared is being replaced with a positive 1. We just talked about it, right? And that's all over. I'm going to do the same thing down bottom. Find my like terms. Here they are. 2I, negative 2I. 2I minus 2I is 0. They cancel out. I'm just going to cross them out. They cancel out. We okay with that? So I'm going to write down my 4. Right? And we just talked about what negative I squared is equal to. What is negative I squared equal to? It's equal to 1. So now, up top, now I can combine the 6 and the 1. 6 plus 1 will give me what? 7. So I have 7 plus I over 5. Okay? And if they want the answer in complex number format, I'm going to splice my denominator, and I'll end up with 7 over 5 plus, now, you all have been writing it this way, I over 5, which is cool. But this is how you're going to see it in the text. 7 over 5 plus 1 over 5 I. Okay? And that's it. Shantasia, you feel better? This is going to be your seat from here on out. You know that, right? Don't be looking over there. What's over there? Angel, how you feeling?
If I catch up, can I sit back there?
We'll see. This will be this y'all on a week trial. Let's see how this next week goes. Because I don't trust y'all over there by yourself. And Miguel, I'm watching you too. You better keep up the good work, otherwise you're gonna be over here with me. How we doing on Delta Math, y'all? Oh, a hit dog will holler every time, won't it? What you doing? You ain't got no business. Alexis. Huh?
What?
What? You telling on yourself.
What did I do?
You're not doing Delta Math.
I didn't.
Let me see.
I
I ain't betting you nothing.
Exactly.
You too confident. You too confident.
Exactly.
Let me see. Let me see. So how you do?
Well, I got 3 of them. I did 3 of them, but I was missing the 1, which is.
What? You missing the one? That means you got one more to do. Don't jump too bad now.
I'm doing the one. What's it called? The one I told you about the simplifying.
Oh yeah.
That's
The
what
one
I
went
asked
over?
you. Yeah.
Okay.
That's
So,
the only one I need.
you good? I went over?
Yeah, I went through it.
So you telling me that your divide and complex numbers assignment is done? It's done. What you talking about? Divide and complex numbers.
Are you talking about the one that you sent us yesterday?
No, the one I assigned you today.
I didn't do that.
Oh, okay.
No, I didn't do.
And you over here jumping back.
I was
Let me pull up your account. I'm about to put it on the screen. The only 2.
Yeah.
Shut the back.
I did the other 3.
Do them all.
I am.
You sitting there with your chest out like, I'm done with everything.
Hey, you gotta be confident with everything.
I should have put some money on it, huh?
Yeah, but you did.
I did not. Should have put some points on it. Anybody got any other questions about dividing? We good? All right. I'm gonna stop the recording now.